Good morning, good evening, HVAC. This is Mr. C. We're doing a late night special this week. It's about 10 o'clock for me, so if I sound sleepy, that's what's up. A little self promotion here. What do you guys think about this Civic that I traced? I think it looks pretty good. And I know you guys miss me so much. I've got a joke for you. I had to scour the internet for an HVAC joke, but I found one. So, I got in an argument with a HVAC technician. It got pretty heated. Oh yeah. Oh, you know you missed it. Alright guys, so week 3. Week 1 we talked about the heater, that was pretty simple. Week 2 we went over what the Freon does in a very specific scientific way. Today we're gonna focus on the electronic controls and kind of the HVAC system overview, if you will. And next week I have an extra credit quiz for you guys if you need extra credit. Normally we do ASC, so I think next week, if we're still not back in class, you can hear me fuss the ASC. And I'm kind of toying with this idea that we meet up because I know we're not supposed to, but if any of you guys want to meet and let's look at a vehicle, put our hands on something, I think I'd be all about it. So I don't know, when you guys call me later this week, let's talk about it. If there's any volunteers we want to get together sometime next week on your day off or something, let me know. So also a little update, I got a new headset, so hopefully this mic sounds much better. I tested it quite a bit trying to get it just right, and I didn't hear any more clicking, so ta-da. Alright, how I normally start class, it's week 3, it's crunch time. I know you guys have been slacking on CDX, we've got to get it done. You only have until April 25th, and I just have this feeling in my guts that since we're not seeing each other face to face, and that I know work is hard on all of you guys, I know everybody's starving to death and everybody's stressed out, that I just have this feeling nobody's doing their homework. I want to reiterate that HVAC is the smallest chapter, or the smallest module in CDX. I think there's only 3 chapters. And remember guys, you really just need to nail the chapter finals and the module final, and you'd still pass. So I really don't want to be chasing you guys or doing any of the 900-word essays about that stuff. So I'm going to drop it. I do need to fuss a few of you. Half of you called me last week like I asked you to, and half of you didn't. If you did not, you did not receive attendance for last week. If you do, so here's the thing. Last week, if you didn't call me, you did not receive attendance, which is the biggest part of your grade. However, I get that everything is stressful, we're trying something new, maybe I wasn't as direct about it as I needed to be. This week, if you call me, Thursday or Friday, whenever you can, I prefer about 5 or 6, but whenever, and we talk for 5 minutes, then I will go back and make your attendance for last week look good, along with this week. But I need you guys to help participate with this because otherwise, I can't prove you guys are doing your work, and we all signed up for this. So, all right, enough about that. So let's go over a few things that we went over last week, and I would need to reiterate here that if you didn't grasp fully what we went over last week with what the refrigerant is doing, where and when, then you need to go back and rewatch it. If you have questions, call me. I'm home with the kids most days of the week. The clutch, I shot a little video. I'm so irritated with this clutch. It's not gonna get done because I need parts. So I'm just kind of twiddling my thumbs for right now. So call me. Let's talk about HVAC. All right. Anyway, so this chart is a famous chart, and duh. Let's go backwards a second. If you would like a copy of this week's worksheet, find your way to CDX. Click on heating and air conditioning. The very top announcement shall say HVAC Week 3 worksheet, and you can click right here to download your very own copy of Mr. C's world famous worksheets. Alright, so over here on page 1. I told you guys pressure's not the way to test, and This is a great example of what's going on in the real world. So, alright, who can remember from last week or the week before? I keep saying these numbers because you're going to need them for ASE and CDX. Technically, Freon pressures are supposed to be, who remembers? Come on, you guys should know this. Low side should be 20 to 40 psi. High side should be 170 to 230. So let's find that area here. Can you guys see my mouse? I'll put it on the left side so you can see the mouse. So we said 20 to 40. So that's ambient temperatures on here on this low side. We're looking at the low side in the middle here. That puts us at between 65 degrees and 70 degrees outside. And it was nice and chilly Monday of this week, but by Thursday it's going to get back up to 90. And 90 is not even that hot for where we live. So let's get more realistic here. Where we live, summertime, the vehicle comes in hot, the pavement's hot. The front of the vehicle is going to be much closer to 100 degrees Fahrenheit, where the pressure will be nearly double. If we said the average between 20 and 40 is 30, right? And this one says 50 to 55. That's nearly double as much pressure on this low side. And there's absolutely nothing wrong with it. It's just as pressure increases, temperature increases, and ambient temperature outside of the vehicle affects this 100%. So we need to be mindful when we look at gauges of what the temperature is outside. And last week when I took my digital thermometer and I stuck it in each vehicle, what you didn't see was before I did that, I turned it on to see what the temperature was outside, and it was about 76, I believe, when I did the Highlander. That way I have a kind of an idea before I even go looking what I should be expecting. And then on the high side, let's find 170 to 230 puts us at about 80 degrees to 85 degrees. And it's going to be hotter than that next week. So really, let's go find our 100 degrees Fahrenheit down here. We should expect pressures of 320 psi, which is the upper limit of the ASC and CDX. But if you saw a vehicle with pressure 350 down here, there may not be anything wrong with it. It might just really be hot outside. So again, I just can't say it enough. Pressure is not the way we diagnose here. It's helpful. It'll tell you if the compressor's moving refrigerant around, but it's not gonna help you make a sale. It's not gonna give you the confidence that you'll need to tell a customer with your one shot, because we get one shot at this, right? Interestingly enough, I don't have a picture, but my neighbor has a Dodge 3500, the big one, and he was outside yesterday with the hood open, so I walked over there, and he's got one of those. Oh, look, we got the Googles right here. Hey, check this out. What do you think about this? Turn my Blue Brew into one of those. We need a tab over here. So let's go to O'Reilly's. We'll go to O'Reilly's right now. Boop. And let's find some refrigerant. Let's just put Freon. I bet O'Reilly's would call it Freon. No? Okay. Refrigerant. I can spell. We would love if you wouldn't just shut up. R1348. Yeah, that's probably a better way to call it. That is what we want. Alright. Well, they sell us some. Oh, these are tanks. Sweet. Okay. That's cool. I was not expecting that. That's not what we want, though. They don't have the gauge on it. We want that cheap little bastard that comes with a gauge on it. What else could we call this? What do you guys call this? Let's put Freon back in and see what happened. Universal parts. I don't want that. I want... Yeah, what happened with here? Refrigerante. Recovery. R134. What do you think YF refrigerant stands for? Alright, we'll hit that. 22 leak detectors. We'll hit all of it. Let's see what we find. We want that cheesy little bottle that says super cool. Super cooling off your stuff. Others die. Oh, I had one of those guys when I was young. AC leak sealer. Oh lord, y'all don't ever put anything in your vehicle that says sealer. Oh, here we go. Ugh, leak stop. Bro, that's the can AC Pro. What if I put AC Pro in? Can you tell I'm a tech and not a parts guy? Because I don't know. Oh, fine. Anyway. So, it'll be a cheesy bottle like this. This one doesn't have a gauge on it most of the time. So, he's got one of these cheesy cans with a gauge on top. And he's outside, he's trying to put Freon in it. And I said, well, what's the pressure on it? He said 35. Okay, well, that means there is something in it. But that doesn't mean it's refrigerant. It could be atmosphere, but there is some pressure, so that means the compressor is working, and we can hear the compressor cycling. Remember, I talked about that a lot last week, and I showed you guys on my car the compressor cycling. So that's probably not the problem. Um, it had a separate fan for the condenser that wasn't coming on. Part of the problem, though, is this Dodge Ram is a 2008 model, I believe, so it's more than 10 years old, and we saw that it had some pressure, and this is the point I was trying to tell my neighbor that I wanted to. I thought about you guys when it happened. So we know there's something inside, but in between that AC compressor and the rest of the car, we have some rubber lines. So I'd love for all the lines to be metal, then they'd never leak. But the engine moves around a little bit, especially when you start it or you rev it. So the compressor that lives on the engine, in order to attach it to the rest of the system, we have to have some rubber hoses. And you guys know this from checking tires all day, that rubber is not airtight. Your tires lose 1 psi a month, even if they're brand new. There's just nothing wrong with them. That's how rubber works. So the tires are, what do you guys set tires? Camrys are 32 psi, blah, blah, all day. We're talking about maybe having 350 psi of pressure. Don't you think some of the refrigerant is going to leave out of those rubber hoses? And then what's interesting is the Schrader valves and the rubber hoses over time will allow atmosphere into the system. So there might be something inside of it that is pressurizing. That doesn't mean it's refrigerant. That is, again, a big reason why we need to pull the weight out. So many times I've seen where the pressure looks great and we pull it out and the weight is about half, and there's really nothing wrong with this vehicle. It just is 10 years old. You're gonna lose some refrigerant and you're gonna gain some atmosphere. That's just part of life. So, little anecdote for you guys. Let's go down here. This is kind of a review, so let's go through this together. We know that pressure and temperature are related, but what do we do to manipulate? What do we manipulate to control the temperature of refrigerant in the AC system? And you guys had better know this from last week. The way that we make this happen is we change pressure. Oh, I have a cool little thing. Oh, we're going outside. Hold on, let me pause the video. I thought of this today. Let me find the stop button. So, Mr. C's life lessons. Let's come out here for a second and look. So I'm replacing this clutch on this Mazda 3, and I let the customer order the parts because I didn't want to have to be involved with the money. So here's the throw bearing that came out of the car, and here's my shift fork. Right, that looks like it fits, yeah, because that's what came out of the car. And here's the obviously not right one. And this is what I really should have done first: is the tool you use to line everything up. So the new clutch kit comes with this tool, right? So of course it fits in the new clutch. New pressure plate, very nice. So, yeah, yay, fits the new one. But is the new one the same as the one that came out of the car? No! Oh, I should have checked. I'm so irritated about this. Don't let the customer order parts. I know better too. It's not even Exeti's fault. So if you guys don't know, Exeti is the best clutches. For the price, that's the way to go. Alright, so here's my idea. I want you guys to do this and think about what's happening, and then we're going to talk about it. So you've all done this at work. You got some brake parts cleaner, and this is me trying to spray myself and angle the camera at the same time. So y'all bear with me. All right, so I'm going to spray my hand with the brake parts cleaner. Put a glove on. There you go. Get it all over you. All right, now. we know that brake parts cleaner is mostly alcohol. It evaporates very, very quickly, right? So what is going on in my hand right now? So I want you to remember what we just went outside and did, and then we're gonna run through this quickly, and then I'm gonna ask you about that brake parts cleaner again. So we always start over here with a compressor. I hand drew this time, I don't know why my drawing pad is so crazy. So I go. No, not, here we go. So I leave compressor and I go over here to condenser. Because I'm leaving the compressor, we know that I'm a high pressure, so I do my little H on this branch. I know I'm going to be high pressure. Alright, I leave condenser and I haven't hit the restriction yet. I'm still high pressure because we divide this guy vertically, high pressure and low pressure, right? So I was under high pressure until I got to this restriction, and it limited how much refrigerant was allowed past. The little bit of refrigerant that got past is now exposed to a big empty container, and because there's nothing in it or very little volume inside, the pressure is very low. And we know that my pressure is going to remain low until I get back to compressor. Okay. Alright, now so we split it this way vertically. I'm so stupid. Horizontally. Sorry, guys. And then now let's split it vertically. So when I condense, I go from a what to a what. So over here, now I'm a liquid. I just condensed down from a gas, and over here I'm a gas. So we'll just boop, do that again. After I evaporate, I become a gas. Before I evaporate, I'm a liquid. Alright, cool. High pressure liquid, high pressure gas, low pressure liquid, low pressure gas. Cool. Okay, so we got that out of the way. It's like I draw it like that on purpose. Now, let's talk about temperature. Alright, so we know we want to go into the evaporator core, scoop up a shovel full of thermal energy, take it outside, because over here is in the cabin, take it outside to the front of the vehicle and dump it at the condenser. Okay, so we know that's what we want to do. Right here I'm going from a liquid to a gas, and in order to transform the refrigerant, it's going to require a great amount of energy. And let's not misunderstand here. It's not that by moving it quickly or putting it under high pressure, right? That's not giving it energy. I know that is kind of confusing, but what we're doing is when we go from a high pressure to low pressure, and remember that changes the boiling point. So what we've done now is we've changed the boiling point, and it's going to change across this evaporator core from a liquid to a gas, and in order to do that, it's going to have to absorb some thermal energy, right? So when it evaporates, it becomes cold. Well, there's no such thing as cold. Haha. When it evaporates, it removes a lot of thermal energy from the surrounding air, and we go out to the front of the car and we force this refrigerant to condense back down. And in order to make that happen, I'm on high pressure on both sides, so it's not the pressure here. Well, sort of. Anyway, before I open my mouth and put my foot in it, as we travel across the condenser, it condenses obviously, and in order to make that happen, we're gonna have to get rid of a bunch of thermal energy, right? So we go back to when I sprayed my hand with that brake parts cleaner, and if you guys haven't ever experienced this, next time you're at work, do this. We know that brake parts cleaner is mostly alcohol, so it evaporates very quickly. The boiling point when it's going to evaporate is very, very low, right? And it's not hot in my garage, but it's 70 degrees this evening. And I don't know if you could see how quickly it was drying. One of the reasons we like to use brake parts cleaner so much is because it dries almost instantly. It washes off whatever gook or grease or whatever we don't want, and then it doesn't leave a lot of residue. WD-40 sucks because it stays forever. So we know it's going to evaporate very quickly, and when I did it to my hand, it did one of two things. It either absorbed a lot of thermal energy or it got rid of a lot of thermal energy. And so that's going to be my question for you guys this week. Um, if you haven't done it, go to work and do it, or if call somebody if you're not at work. It doesn't have to be brake parts cleaner. You could do it with swabbing alcohol because it also has a very low boiling point. So you ought to be able to sort this out, but it's cool that you can feel this sensation happen on your hand and then understand why, what is actually going on. So I thought that would be a fun little thing. All right, back to this worksheet. So what are we going to manipulate? We're going to manipulate the pressure, and that's going to force the refrigerant to either evaporate or condense. This summer, should you expect to see an automobile with low side pressure at or near 50 psi? Yes, you absolutely should. On the low side, there's nothing wrong with it. It's just hot outside. How high should I expect the high side pressures to get? Don't be freaking out if you see them over 330. There's nothing wrong with the vehicle. It's just hot outside. So this term state of charge we're going to talk about next. And this is referring to volume and capacity. So if the vehicle says it's supposed to hold, let's pull one out like we did last week. If the hood sticker says what did we use last time? A Nissan? Let's get something different. This is a big one. What do we have here? Oh, Toyota. So it says we should be using R134, and it should be 470 grams, give or take 30. And then this is my oil over here. So state of charge, we're talking about whether it's overcharged or undercharged. And naturally, the vehicle is going to want to lose the refrigerant. So if nobody's touched the vehicle, and even if there's nothing wrong with it, it's just been over time, we're going to be low. Overcharged is when homie decides he can do it himself. And I told you my story last week about us putting several cans into that Eclipse because we were stupid. And then now we have an overcharge problem. And both of them are dangerous, and both of them will make the compressor explode. So we need to be careful about this. You really don't want to be the last one to touch the customer's vehicle. So I'm saying it like this because I'm trying to hit home with you right now. So the customer came in, hey man, my AC just isn't great. I'm not sure about it. Can you look at it real quick? And you throw the gauges on it. And the gauges look somewhere about right. And we didn't know it was overcharged or undercharged because pressure doesn't tell you that. And then it leaves, and then a week later, the compressor grenades, and they come back, and they're very upset because you touched it, and you told them it was fine. So now they want something for free. So it's just worth the time to use the AC machine and pull everything out. Does Freon behave as we would expect? Volume and pressure? No. I preached to you guys about that last week. On page 2, this is the chart that HVAC students, and I don't mean you guys in the HVAC module of automotive, but proper HVAC, that's what they do all day, commercial and residential HVAC, normally get this math. This is a bunch of math for you. If you're into it, here's the link. I'm not going to go over it. This is for CO2, but this is the part that I wanted to show you on the next page, on page 3. Last week when I drew it for you, I showed you that as you put a small amount in, the pressure ramps up very quickly. And then you could keep adding more and more and more, and the pressure kind of doesn't really change. And then finally, when you're way overcharged now, the pressure starts to go up again. And this is for CO2. This isn't for refrigerant, but they behave very similarly. All right. So, and just a review of last week, what is the number one reason the AC system isn't working? Is the refrigerant level is not correct. Now, the refrigerant level not being correct caused the compressor to blow up, but the original concern is always going to be, so like step 1 is we have to find out what the refrigerant level is. And what does that cause to fail? The compressor. When the compressor blows up, there's a chance shrapnel will be in the desiccant sock now, so you gotta change that out too. And here's a little bit of motivation for you down here. In my years working at the dealership, the most misdiagnosed thing was AC, and you'd think it'd be check engine lights. And the problem with check engine lights, or the problem with HVAC, is different. If you guys pull a check engine light and get a code, then you go straight to the book and step by step it tells you what to do. But there's not a repair manual for HVAC, and depending on who taught you, you were taught correctly or incorrectly. So this right here is cute when the system holds 5 pounds, okay? You're going to be pretty close if the system holds 5 pounds. But everyone that we've pulled up has been 1 or 2 pounds or less. That Dodge Ram I looked at yesterday, the 3500, the big old truck, only held 1.1 pounds, right? So if we're half a pound off on a system that only holds 1 pound, it's absolutely going to affect things. So, you guys have just got to make sure you're checking weight. Number one, got to be checking weight, and then deciding which direction we're going to go. So I put down here my kind of quick steps to reiterate this one more time for you. Vehicle comes in, customer states the AC is not feeling cold. So I'm obviously going to drive it into my bay. On the way there, we're going to check with our hands, turn it to max, whatever we're going to do, recirculate, turn the temperature all the way down, set it to your face, roll the windows up, all that stuff. And we're going to put our hand on the vent, and that's going to tell us it either is or is not, but it's not going to tell us if it is, if it's working great. And while we're doing that, we're listening for the compressor cycling. Because if the compressor is not cycling, I know I'm going this way. If the compressor is cycling, I know I'm going that way. So the compressor not coming on. Oh, is my drawing still up? Yeah. So the compressor not coming on could be caused by pressure sensor. So there will be down here pressure switch or sensor to help protect the system, because when the refrigerant level gets low, there's nothing to move the oil around, and if there's no oil lubricating this compressor, the compressor will blow itself up. So whenever the pressure gets low enough, then the compressor is not allowed to come on. So let's make this a little bit more complicated, and then we're going to look at a wiring diagram later. But we've got the HVAC module, because you know there's a computer just for that now. We've got a button inside the car that says snowflake. I'm a pretty snowflake. Okay, you push the AC button. I'm the AC button. And it asks the HVAC computer, hey man, can I turn the compressor on? And the HVAC computer says, well, we better ask this pressure switch, hey, is the pressure okay? And then it's going to tell the HVAC computer yes or no. And if yes, then we're going to send voltage to the compressor. And if not, then we're not going to. So if the compressor's not coming on, I first want to find out if there's any voltage going to it. So what's nice about this is most compressors only have one wire on it. We talked about the clutch last week. When 12 volts hits that clutch, it creates an electromagnet, pulls the clutch in, compressor's on, and then it grounds itself out because it's bolted to the engine block. So this electrical circuit is super simple. If the compressor is not cycling, all I got to do is pull this wire off and use my test light to see if it has voltage. If it does have voltage and the compressor is not cycling, then we're done. The compressor's failed. If I don't have voltage coming to this compressor, now I need to start looking at other things. If it was me, my next thing is I would check what the pressure is. If the pressure is 30 psi, there's no reason for this switch to have failed. Now I might go get the wiring diagram. If the compressor is cycling though, which it probably will be, then what we're going to have to do is pull the Freon, the refrigerant. And we will find that it's either low or high because it was leaking and then it was leaking and somebody put more than it was supposed to have back in it. So overcharged and undercharged is what we're going to go over next. And in reality, it doesn't matter. You're going to diagnose whether it's undercharged or overcharged. It doesn't matter. We're going to continue with the same steps. But the book and ASC have a lot of questions about what will happen. So, one thing though that is a clue, and I'd like for you guys to get to on that step where you're pulling the vehicle into the bay. So, I'm not going to read this page to you, but we're going to talk about what happens. So, while you're pulling the vehicle in the bay and you're listening to it cycling, if it is overcharged, then this compressor is not going to run for very long, right? So here, let me try to delete some of these lines and clean this up a little bit. Okay, so if this whole system has more refrigerant than it's supposed to have, then the moment the compressor turns on and starts moving everything, then the pressure is going to jump and be too high. The pressure switch will say, hey, turn it off, and the compressor will turn off. And it will stay off for a while we're waiting for this pressure to drop, for it to slowly get worked through the evaporator core. And then the pressure finally drops enough, the compressor will come back on, but just for a moment, and then turn off again. And that's a symptom of the system being overcharged. What you're much more likely to see, because the refrigerant left just happens naturally, or there's a leak, is if the compressor is cycling and the duty cycle is more on than it is off. So it comes on, turns off, and it comes back on, and it turns off, and it comes back on. What's happening is I don't have enough refrigerant, so it should be a duty cycle of 50-50. See if I can sketch that cleanly here. That's on, this is off, duty cycle, leg of on, leg of off, right? And then overcharge would be, oh, I missed a line, you're fired. Overcharge would be a duty cycle like this. I was on for a second, and then was off for much longer. Then I was on for a second. I did it again. Anyway, so that's a helpful thing that you could tell. So if you guys knew me when I had the Accord, it cycled constantly because it was undercharged. And then the Dodge yesterday, part of the reason I was telling him not to put any more Freon in it is it had an overcharge sort of cycle to it, which is, hey man, let's absolutely not put any more in it, right? So let's go back to my drawing. Which one is more dangerous? Which one is going to cause more problems? So I feel that they're equally dangerous. This is not a, remember, an engine performance. If the engine is lean or rich, which one is more dangerous? And one of those is clearly more dangerous. Here, I feel as if both of them are equally dangerous. If there is too much refrigerant, that is going to wear this compressor out. If he's having to fight backwards, I want you to think about, if you guys haven't seen the inside of a compressor, we have one in the shop that I would be showing to you now. See if I can find a AC compressor tear down. No, just like images, bro. All these little pistons. Here we go. Check this guy out. Yeah, so that's what it looks like inside. Or really any compressor kind of works this way. So if these guys are having to fight the refrigerant behind it, it's going to tear this thing up. So overcharge will kill a compressor. If there's not enough refrigerant to move the oil, we said that will kill the compressor. In either case, when the compressor does explode, then that shrapnel is going to move this way to the condenser. If you're lucky enough to have that desiccant sock, that should catch it. If you're not, then it'll continue into the receiver dryer if that's the sort of desiccant you have, or the restriction will catch it. In neither case will it ever make it to the evaporator core, so don't you dare try to upsell somebody that, I'll smack you. Oops. Alright, it's time for my favorite part, is the electrical bits. All the vehicles at work have automatic AC, so some of this is about the automatic AC. But I think some of it is interesting. So, for example, this ambient air temperature sensor. Do you guys know what I mean when I say that? It's on the dashboard. Let's get a picture of it because it's 10 o'clock. I'm not walking out to my car. Ambient temp sensor. Now, where it is on the car? It's be on your dashboard. Yeah, okay. Normally it lives out here in the front of the vehicle. And so this way your head unit says it's 84 degrees outside. And I totally think it was a gimmick. It showed up and I think it was just a fancy bell and whistle so that Toyota or Honda or it's probably Porsche or BMW could say, look what our car does. It'll tell you what the temperature is outside, like we really care. What is interesting though is in addition to obviously it helps with the HVAC. When you put the HVAC on automatic and you set it to, hey, I want it to be 64 in here, and it needs to know what the temperature is outside so it can decide if it even needs to be on. Should it be on low? Should it be on high? Should it be on hot, cold? What is even cooler though is this is engine performance now. So we said that when the temperature is very cold outside, the air is more dense. So the same volume of air is getting pulled into the engine, but the mass is different. And that'll affect whether it's running rich or lean, right? And then you get in the car later that afternoon after it's warmed up, the air is much less dense, and so you have a different situation. Um, with modern vehicles, if the engine is cold and the exhaust is cold, the O2 sensor isn't reliable yet. So you can't really rely on the O2 sensor until the engine is warmed up to make those kind of decisions about if we're running hot or cold. So what's cool though is after some learning and a little bit of engineering, the modern vehicles now will behave differently. If it is 32 degrees outside, it is going to idle very high because it knows it needs to pretend to be choke. Whereas if it's 115, it's not going to because it knows it doesn't need to. So I think this is cool. Um, it's pretty simple. It's just voltage. None of these have moved to waveform pattern. They're all analog voltage. So I'm not going to go into this. I don't like this description here. I pulled this from CDX. This is, this would be one brand. I'll tell you right now, this isn't how a Toyota one works. But so the cabin air temperature sensor, where does he live? He's going to be under your glove box. We need to know what the temperature in the cabin is so we know if we're achieving what we want and when we can turn off. So this guy is your efficiency guy. This guy's in charge of making sure that we use as few resources as possible because every load in this car increases or rather decreases fuel efficiency, right? So if we can turn something off, the blower motor, if we could turn the compressor off, if we can do something to take one load off, then we'll get better fuel economy. So this guy's job really is to kind of tattle on the inside of the. It works the exact same way as the one outside of the car, so there's nothing special about it. Neither of these are going to be damaged. Neither of these are going to break. I've never replaced one unless the vehicle's been wrecked because this ambient air temperature lives in the front, but by itself, it's never going to fail. This guy's protected underneath the dash, so unless they've been, I don't know, partying in the car and it's full of garbage or something. Engine coolant temperature sensor, why would we need this for HVAC? So this is important for engine performance because I want to know if the engine is warmed up. That has a lot to do with so many things in the engine. But why do we care about that for the HVAC? Well, we said, what was week one about? The heater? And the heater only works when who gets warm? So am I gonna customer got on the vehicle and they cranked the temperature to 80. I want it 80 in here. And ambient temperature sensor says, well, it's 30 degrees outside. Okay, well, the HVAC module, not that it's really making decisions, it's been programmed this way, but follow my logic. HVAC module says, okay, cool. Should I turn the blower motor on high now and then hit them in the face with 30-degree air from outside? Or should I wait and it's not cold enough for you guys to test this right now, but next time it is cold, you can absolutely see that as the engine temperature gets warmer, the blower motor will go up from like low to medium, medium to high, and start blowing more air. But it waits until the engine coolant temperature is hot because then it knows the heater core will be hot. So that's kind of interesting. This guy, the engine coolant temperature sensor, when it was designed, had nothing to do with HVAC. right? It was all for the engine performance. But we can take this information and use it to help other things. And so this is part of why the wiring diagram is really complicated. But I think it's really cool that we're using all this information. The sun load sensor, again, did not start off life as an HVAC component. The sun load sensor, let's see if we can find a picture. There's one in my wife's Highlander. Is always on the dashboard, right about, I wanted an actual picture though. This guy, always in the front of the dashboard by the glass. And his whole jam is to see if there's sun. And this started off life for the automatic headlights. So when you drive under a bridge and your lights come on and the radio dims and then you leave the bridge and everything goes back to normal, that's what's going on. So these are super easy to test because they're looking for the same kind of light that comes out of your flashlight. So if you're in the shop and there's not enough direct light, you can hit it with your flashlight. That should cause the radio to dim, the headlights to come on, the running lights, all those things. Assuming the vehicle has automatic. Or if you're doing the opposite where you need to see if it works when it's not getting sunlight but it's bright, just throw your repair order on top of the dashboard and that should create that situation. So another guy who began life as something else. Why do we care if, as far as HVAC, if the sun is out? And so this is kind of a niche thing. If we have a passenger and driver side split HVAC unit, and you guys know what I'm talking about on a luxury vehicle, there will be two of these. One of them on the driver's side, one on the passenger side, because we all know that when the sun is hitting that glass, it is warm on you, right? You're like the only person in the car that's hot because you're on that side of the car that the sun is hitting. And so this now we have two of them to try to tell the HVAC computer, hey, turn the passenger's temperature down a little bit. It's hotter over there. Um, and again, those should never be damaged. They're inside the car. The AC pressure switch we've talked about. They're simple in nature. Now we have a low side and a high side. And really, we're talking about testing it here with voltage. But if it's one or if it's two or three wires, I would just jump it. It would be the fastest way to test this circuit. A lot of times you could just unplug it real quick, and then if that changes the behavior of the compressor, that tells you it is working, right? Um, but if you're afraid the sensor is not working like it could, you could just jump it and then give it the voltage the computer wants to see, and if the compressor comes back on, then you're pretty sure that that sensor went bad. In each of your repair manuals, there will be a testing procedure for each switch because again, this 5 to 4.5 is probably like a Ford or Chevrolet. I feel like all of these numbers came from um, Ford or Chevrolet. So, evap temperature sensor. So this guy is very similar to the cabin temperature sensor, and he lives on the evaporator core, which we know where that is. It's inside the cabin as well. And so why would I need this guy if I already have another one underneath the dashboard? So let's think back to last week when I was talking about what will happen if the air passing over the evaporator core dropped below 32 degrees. Well, the moisture in that air would freeze. So the evaporator temperature sensor is there to make sure that the evaporator core doesn't freeze. Why would the evaporator core freeze? Well, if the restriction got stuck wide open, there's nobody to limit what the compressor is pushing. So in this way, it could tell the HVAC unit to turn the compressor off and keep us from having a freezing up situation, which is cool. It's kind of like a backup safety. You will get a check engine light if that happens, which is also very nice. And those guys will last forever. And this stuff, I'm going to let you guys go through that by yourself, and I'll meet you on page 7. Alright, I lied. We're going to skip over to page 8 because 7 is what I've been going over. So on page 8, let's step back and we're going to kind of talk about controls and pull the whole system together here. So we've got doors and we've got buttons. So we're going to start with the buttons. I know I did that backwards on the thing, on the sheet here, but we're going to sketch it out first. So we always have at least 3 knobs or buttons. So on the one, we've got the mode. We call this the mode door. We've got the blend door. And no, this is not Folger's morning blend. Blend door. Oh. Blend. And we have the blower motor speed. That low. So I'm going to do B motor speed. So this would be how fast you want the fan speed. And we're going to call it the blower motor. We're not going to call it the fan. There's already cooling fans on the vehicle. So we're going to have a minimum of those on every vehicle. So here's what it looks like out of a Dodge. On the left here, we got low. We got 2 mediums and high. So that'll be my blower motor. In the middle here, we have what we call the blend door. And now that you see the colors on it, it makes better sense. I'm blending between the hot or the cold. I'm blending, do I want to go through the cold would be I'm going past the evaporator core, and the red would be I'm going past the heater core. And then I was thinking about this while I was drawing it earlier. If you guys struggle to remember which is on the inside of the vehicle, with the heating circuit, we have a radiator in the front and a heater core on the inside. So on the AC in the front we have a condenser, and on the inside we have an evaporator core. And so when I was a white belt, that extra word core, if somebody called it a core, in my brain that meant it was inside, so that helped. And then over here on the right we've got the mode. So do you want it, this is right on the windshield, here's the windshield and your feet, here's just your feet, here's your face and your legs. And then right here, this is interesting, and I'm going to talk about this a little bit later. Right here, it doesn't indicate that you are getting recirculation, but recirculation door is one of the 3 doors that we're going to talk about. So on some vehicles, you'll get an extra little button. So maybe, here we're going to draw. This is super fancy, you guys. Maybe we'll have a snowflake. Oh, let's do it in blue. Little snowflake. Maybe it'll say AC. Either way, this is, hey man, I want to turn the compressor on. And then we'll have one more over here, and it'll have this kind of recycling looking kind of arrow guy, and that's to turn the recirculation on or off. So those are our 3 knobs we're gonna have: mode, blend, and the blower motor speed. And then we're always gonna have an AC on or off button, and then we're gonna have an option for recirculation. And the AC button is hilarious. I wish I was making this up. Customer states the AC is in op. Is a brand new Camry with maybe 30 miles on it. And so I went out to it was still on the drive, and there was a very old man, and he came out to me. He said, "I'm so sorry. I'm so sure it's my fault. I left yesterday and the AC was working great, and today it's not doing anything." And I got in it, and the AC, the little snowflake, because on what we worked on at Toyota, it was a snowflake at the time, and he had come from a Ford that had the letters AC on it, and he didn't know what it was. It was that simple. Read your owner's manual. So we've got those knobs, roll, 3 knobs, and these 3 doors. So remember last week I showed you guys pictures of the HVAC housing, right? So we've got 2 of them here, and like this guy on the left is looking at it from, this is the passenger side over here on the left, and this is the driver's side over here, and we know that because there's the blower motor. So I'm going to draw it reverse from both of these pictures. These are looking at it from the firewall back. I'm going to draw it for you the other way. So if we were inside the vehicle, sitting in that chair looking at the front of the vehicle, I like to draw it this way because it's how I remember it. It's going to come in the passenger front cowl. So fresh air is going to come in And if you guys have ever wondered why the cabin filter has pine straw on it or leaves, if we go out to the windshield wipers where the cowl is, and if it wasn't dark outside, I'd go show you mine. Let's see if we can. Put the word car in there. So, oh no, yeah, right here. This is a good picture. So, these holes up here in the cowl, that's what we call this guy that covers the windshield wipers. These holes up here are literally where fresh air gets into the vehicle from outside. So this picture right here where homie's got recirculation button on is not gonna pull air in from the cowl, right? And then you turn that off and it will allow fresh air in from the cowl. So we've got fresh air coming this way. So the first door, and I need to pause here. This is just how I've learned it. You can think of this HVAC housing as that hallway in Scooby-Doo with 47 different doors. And the way that we're going to the way we're going to achieve, how many different settings can we do here? We do several, right? The way we're going to achieve each one of these is we're going to set each of these doors to a different position. And then it's going to push air in different directions to do different things, right? So that looks visually like this. I'm either getting fresh air in from the cowl, like this, so the button is just, I'm just fresh air. Right? And then down here it's, I'm recirculated air. Okay. So there is a door. It hinges, right? And there's a door with a flap. And I either have it open, recirculation is off, and that will pull fresh air in from the cowl into the cabin filter, which now lives right here, right? This is the part you guys see every day behind the dash, behind the glove box. Or you turn recirculation on and this flap moves. So if these were hallways, I'm going to try to draw this. I draw this much better on the whiteboard, you guys. So if I was going to turn this to recirculation, then this door would move to this position here and close off that passageway, and fresh air would only move in this direction. Okay, so that's this idea of this door. I've got different passageways and I'm forcing the air to go one way or another. Actually, we'll do the blower motor. Okay, so next we have the blower motor, and he's always underneath the dashboard. You guys see him all the time. And you know that when you pull this cabin filter out, if there are leaves, they fall down in the... No, I gotta take it out. Draw some leaves in there for you. Some straw. Alright, so now we're gonna leave, and we're going to the next door. So it doesn't look like this in the, because I got a picture of it. It's all very condensed for space. We make all that stuff happen in these itty bitty little, but to understand it from a functional standpoint. So now we've got this option. So I left the blower motor and I went this way, and I've got air moving here, and I can split now, and I can go. So on this side and this, through door number one, we've got, I'm going to draw it blue, cold, evaporator core, and as long as the AC button is on, that evaporator core will be removing thermal energy from the air, right? And then next to him we have the heater core, and as long as the engine coolant temperature is hot, we will be getting the opposite thermal energy dumped into the air. And so when this flap moves, the blend door, we're blending, then we're going to push air either into the hallway. We're going to go over here and absorb a bunch of thermal energy, or we're going to go down this hallway and we're going to lose a bunch of thermal energy. Or, and we like to say blend, because he doesn't have to be fully one way or the other. So in the pixel here, if you set this guy to the middle, then that door will literally be halfway in between, like it is in the illustration here. And then what you feel outside is a mix between whatever the AC system can do and whatever the heater core is doing right now. If we move it 3/4 of the way, then we have a situation kind of like this, where I'm not fully closed. And then let's turn it all the way cold, and we'll get a completely close that pathway off, and we'll push all the air past the evaporator core. Now, I like to note this for no reason, nobody cares. If we wanted ambient air from outside, I don't want it to be affected by anything. I just want fresh air in my face from outside. Then what we would do is we would have recirculation off, so fresh air would come in. We're going to turn the blend door here to all the way cold. So over here, all the way cold. That's going to force all the air past the evaporator core. But as long as I don't turn the compressor on, then this guy isn't doing anything, right? And then I would end up with fresh air from outside. And then our final door, so we've got 3 knobs and 3 doors. My final door, boop, just like the other doors, he just pivots. They're super simple. I'll show you a picture in a second. And now we've got the last selection. Do I want to go to the windshield? Do I want to send air out to your face? Do I want to do your face and your knees? Oops, more like this. Do I want it to come out on your feet? Okay. And then this is where there's so much tubing on the inside of the dashboard, not shown in here. You know, it would snap to these guys here. I think I have another one here. That's from the rear. So in theory, this is pretty simple. I just remember my 3 knobs and my 3 doors, and this is how I'm affecting what's going on. Where they are on your vehicle is going to be different on every vehicle, so you'll need to find it in the repair manual. All of these, the motors that affect these doors, are located externally to that housing, so you can change them. So let's do blend door motor. So they're just little motors like this. I'd love to see one on it. Heater core. No, that's not a good picture. Remember, we could see mine last week. Yeah, check this out. So here's a blend door actuator. There, it'll be 2 or 3 screws and 1 connector. So you might have to move a glove box out of the way. Maybe you'll have to take one of the lower kick panels. Oh, here's a good picture right here. So you're going to be crawling up under the dash, but you don't have to take the dash out, which is important. This is a great example here. If we can get a good picture. Man, I want this blown up. I don't know if you guys can see this. So we're going to put the motor onto the blend door itself. And there'll be a little nub sticking out, a little shaft with a keyway in it, so it only goes on one way. And the reason that this is important is the door will only move so far, right? So in my illustration here, this door can only go so far. If the motor fails and the limit switch no longer stops it when it's supposed to stop, you'll have a condition where maybe you touch something, I don't know, anything. Maybe we move the mode right here, and then you hear a knocking underneath the dash. Knock, 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 knock. What that is that motor is trying to continue to rotate, and it can't because the door is all the way. If you hear that, you need to, if it's your car, you need to stop touching it. If it's the customers, you need to inform them right now, because this actuator can be removed externally, right? We don't have to take the dash off. We don't have to take the HVAC housing out to change the actuator. But if that door breaks or the shaft breaks on that door, the only way to get to it is to pull the dash out and then split this entire housing. So that's 8 or 10 hours labor. So that's something to be mindful of if and when you guys hear that. It's a very popular thing on GMs for them to knock, 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 and just, ooh, don't do it. This goes from being such a simple problem to being such a big headache very quickly. So that's about it for the lesson. Be mindful that if we have rear AC, so Mama's Highlander or a minivan, or it's gonna have a separate housing in the back. It's normally on the passenger side, and it's built exactly like the one in the front, just a different shape, but it achieves the exact same thing. And I wanted to show you guys heater core and evaporator, because they live right next to each other in this system. In that housing, we're gonna have, this is a really old drawing, that's not what we want. How about this guy? Not quite. Of course I can't find one. Ooh, 85 Lincoln. Google, you're killing me. Either way, failure. But the point is to get to either of them. So in this guy, if we have a problem with the heater core or the evaporator core, or one of those doors breaks, this entire thing has to come out. And this is important when you go to price out labor, because that means we have to drain all the engine coolant, right? That's the heater core, is the engine coolant. And we have to evacuate all the refrigerant, because that's the evaporator core in here too. So you need to consider parts if we need fresh coolant, and then labor time. Get you an hour's labor for evacuating and recharging the refrigerant. Alright, that's about enough. I ran over an hour and I was trying to not to. So Thursday or Friday between 5 and 6, please. And Tuesday morning, I need you to text me. Let me know you're working on your CDX. I'm going to check your grades this Sunday, and that way it's not a surprise on the 25th if you aren't close enough. But either way, y'all get on top of it. Call me if you have questions. I'll see you later.